Hi, everyone. Welcome to our broadcast today. This is the Miami Herald, and I'm Alex Harris. I cover hurricanes and climate change for us. And today we're speaking with Dr. Jennifer Francis, a senior scientist at Woods Hole Research Center. Dr. Francis, before joining Woods Hole Research Center, spent 24 years as a research professor in the Department of Marine and Coastal Sciences at Rutgers. And she's here today, and we're going to have a conversation about hurricanes and climate change, the interactions, the very complicated and nuanced interactions between the two. And we are here to answer your questions. So if you have any questions, feel free to drop them in the comments wherever you're watching, Facebook or YouTube, and we will get to as many as possible. We want to explain this really well today, and we would love to hear from you. Yesterday was our first day of hurricane season, June 1st, and it's a 6-month season. And as we know, in South Florida specifically, especially, we've already had a very active start before the season even kicked off. We've already had 2 named storms this year, Arthur and Bertha, and South Florida, well, the east coast of Florida really caught some serious flooding at the beginning of last week, just from the outskirts of Bertha, and Arthur also brought some rain everywhere. So we are prepared. I hope everyone has their hurricane kits ready. It's going to be a long season, and NOAA predicts it to be a pretty active one, right, Dr. Francis?
That's right. And not just NOAA, but at least a dozen other groups all agree that this is going to be a very rambunctious hurricane season.
Absolutely. I know NOAA's the most recent forecast we've seen so far, and they are predicting 13 to 19 storms this year, around 6 hurricanes, and 3 of those hurricanes could be major storms, which means category 3, 4, or 5. So let's talk about, maybe we can start. This is a very active hurricane season. Does climate change and we've had several active hurricane seasons in a row, how does climate change affect how many storms we get?
Well, climate change comes into play in many ways. First of all, the heat trapping gases in the atmosphere that we've been augmenting over the last 100 years, really. Most of that heat gets trapped into the ocean. So about 90% of it actually goes into the ocean, not the atmosphere. And that's causing sea level temperatures to go up, and a lot more heat contained in the upper levels of the ocean. And that heat in the ocean is the primary fuel that gets these storms going and keeps them strengthening. And really, it's when the oceans get warm, they are then able to evaporate more water into the atmosphere, so more water vapor. And it's really that water vapor that provides the fuel for storms, and not just tropical storms, but all storms. So when that water vapor gets into the air, and then it condenses into clouds in, say, a developing tropical storm, for example, a lot of energy is released into the atmosphere, and that creates even stronger upward motions and heavier squalls and thunderstorms that eventually get organized, if conditions are right, into a tropical storm. So having more heat in the ocean is one of the key factors that's helping to fuel a potential increase in hurricane development this year and for recent years. But there are natural fluctuations that are happening in the climate system as well. The one that affects the Atlantic the most is called the Atlantic Meridional Oscillation. It's a big, long name, but really it just means that there's a kind of a north-south seesaw in the temperatures of the Atlantic Ocean, so that every few decades it tends to be warmer than normal in the north, and then it flips, and then it's cooler than normal in the north. And since about the mid-1990s, we've been in this warm phase of that fluctuation. And that is also one of the big contributors. That's separate from climate change, though. That's a natural fluctuation. But right now, the two things are combining to help create busier than normal hurricane years for the last couple of decades.
Got you. So I know that something hurricane scientists are very careful to say is a hurricane is not entirely caused by natural forces at this point, and it's not entirely caused by man-made climate change at this point. It's an interplay. It's very nuanced. It's complicated. There's a lot of factors that go into it. I know people try to rush to say, this hurricane was caused by climate change, or it was something that climate change had an impact on this storm. And I know that's a science called attribution science. Mm-hmm. But yes, can you talk about why it's kind of impossible to say 100% Hurricane Harvey was caused by man-made greenhouse gas releases?
Right. So hurricanes have been forming forever, basically. So they are not They're not something new. But what climate change is doing is boosting their intensity because of all that extra energy we were just talking about. So there have been some recent research papers showing that intensification is happening more rapidly. That's partly because of that extra water vapor that's now in the atmosphere. There's about 7% more water vapor in the atmosphere now than there was back in, say, the 1970s. So think of that as fuel. We're also seeing the tendency for hurricanes to potentially move a little more slowly. There's been some research showing that. You can think about Harvey, you can think about Florence, you can think about Dorian. Those were all very recent storms that basically stalled in one place and created a lot of extra damage because of it. And that extra water vapor is not just providing energy, but it's also providing more precipitation or more water for precipitation. And that is also adding to the flooding events, say for Harvey, that was so devastating. And pretty much any storm now that forms, not just tropical storms, has more water to work with. And so we're seeing all across the United States, but especially in the East, a major uptick in the frequency of heavy precipitation events. So this applies to tropical storms as well as, regular, what we call extratropical storms.
Right. So weather is obviously a really big, something in modern history we have a lot of familiarity with. Hurricane Harvey, when it hit Houston, dropped so much rain, forecasters had to add new colors to the National Weather Service map just so they could show how much extra rain the city was getting. Can we talk about what causes storms to be more wet and what maybe, sitting over on those warm convection currents and drawing in the Gulf of Mexico, which is something we also saw with Florence off the coast of the Carolinas and Dorian off the coast of the Bahamas?
Right. So it really comes back to the fact that the oceans are so much warmer now and they're evaporating more moisture into the air. And because the air is also warmer now, it can hold more of that moisture so that when a storm does form, it can tap into just extra molecules of water that are available there. And so when you get the combined effect of a storm forming in this moisture atmosphere and also moving more slowly, then the potential for these very, very heavy precipitation producers like Harvey, like Florence, just can dump way more moisture, way more precipitation in a location. I mean, Harvey was just really mind-boggling in that a lot of areas around the Houston city received over 50 inches of rain. I mean, I'm from New England and we talk about snowstorms a lot up there, and getting 50 inches of snow would be a big deal, but getting 50 inches of rain is just like, you just can't even imagine what that must have been like. And especially in a very low-lying, there's really no slope to the land in that area. So the water just didn't go anywhere and it just created all kinds of problems. So it really comes back to this fact that we're trapping this extra heat, which is allowing more evaporation from the oceans and providing more fuel and moisture for the storms to work with.
So while we're on the subject of, hotter oceans causing more moisture, another impact of climate change and global warming is that these warmer oceans take up more space. So for us in South Florida, that often looks like tidal flooding. It's sea level rise. It's that high, the king tides at the end of the year, the biggest, highest tides of the year, which are naturally occurring, are higher than ever. We see the trend over the last few decades is those king tides are getting higher and higher. In South Florida and other places, other coastal locations, you see roads flooded, you see homes flooded, you see cars getting stuck in the water. It's a pretty big deal. So when we talk about those higher water levels with a hurricane coming or a tropical storm, that has a big impact on storm surge, right?
Absolutely. And as you say, half of the sea level rise that we're experiencing is because of that extra heat trapped in the water in the oceans, which causes that water to actually expand. And that, as I said, is about half of the rise in sea levels that we've seen over the last 50 or so years. The other half is also related to climate change, and that's because we're melting the glaciers all over the world and the ice sheets. So Greenland ice sheet and glaciers all over the Northern Hemisphere are all disappearing, both from the top and from underneath in the case of ice that flows off of an ice sheet into the ocean. So those are the two main factors that contribute to sea level rise. So when a storm does come along, that storm surge from the storm and also the waves that the storm generates, both are now riding on a higher ocean level. So they're able to reach farther inland and do a lot more damage than they would have done, say, 50 years ago before we gained about a foot of sea level rise.
And storm surge, as any good emergency manager will tell you, and as anyone knows, is the scariest part of a storm. It's the deadliest aspect of a hurricane or a tropical storm. It kills 88% of the deaths in the United States from tropical storms and hurricanes are due to storm surge or flooding. They always say hide from wind and run from water. So when you, and 50% of people in Miami-Dade live in a flood zone. And the way that climate change is interacting with hurricanes in a very concrete way is that we are now in more danger in the future as the world continues to warm of seeing more storm surge that causes more damage further inland. So that's one of the big issues we have to watch out for as we move forward. But some of the other changes are a little bit more nuanced. When we talk about intensity, like you mentioned earlier, a lot of research has pointed to hurricanes have a better chance of being stronger in the future. So that goes back to attribution science, which is can't say climate change is making hurricanes stronger. You can say climate change is making conditions so that it's easier more likely that storms are going to be stronger, right? It's got that nuance to it.
Right, and as I said, there is research suggesting that we're seeing a signal already that the speed of a storm's intensification is picking up pace. So we're seeing storms intensify more rapidly. There was also a very recent paper suggesting that the frequency of the strongest categories of storms has gone up. And so we're able to now look at the record since satellites started reporting in and seeing that the frequency of those strongest storm types, CATs 3, 4, 5, are in fact increasing in frequency. So, some of the analysis tools that we have and just having a longer record now, starting from the late 1970s when satellites really could cover the globe and show us every single storm that's forming out there now, that record is getting long enough now that we can tease out some of these signals in the data that are difficult to pull out because there's so much variability from one year to the next. And we know that before satellites, there were probably many storms that were not recorded because there was just nobody there to experience them. So it's been kind of an ongoing task to try to figure out ways to measure changes in these storms and what's causing them.
Right. And just to back up to clarify on when you talk about intensity, rapid intensification maybe is what you're referring to here. Right. A good example for Floridians is Hurricane Michael a few years ago. As you remember, when it was crossing the Gulf 3 or 4 days before it hit land, it's Category 1. And then the next thing you knew was a Category 4, which has been now upgraded actually in hindsight to a Category 5 when it made landfall in the Panhandle. And it caused a ton of damage. If anyone has seen those pictures, everything was wiped clean. And that was something that days before people were expecting a much lower category of storm, and suddenly it got stronger. So that is what you're saying is it's more likely to see more of that in the future, a storm strengthening over a short period of time.
Yes, and that intensification prediction is still a real challenge for hurricane forecasters because it's not just the atmospheric conditions, but it's how much heat is contained in the upper layers of the ocean, say the upper 1,000 feet or so of the ocean. And we just don't have good measurements of anything except the surface temperature of the ocean. We can see that in the case of Michael, the sea surface temperatures in the Gulf of Mexico were very far above normal, but we didn't have any data for how much heat the layers below that contained. And it turned out there was a lot of heat there. And so as the storm starts churning up that water as the winds increase, if there's cold water lying underneath the surface, then it's not going to intensify very much. But if there's a lot more heat under there for it to tap into, then the storm will intensify rapidly. And that is still an ongoing challenge with hurricane forecasting. And that's why the intensity forecasts really haven't advanced as much as the tracking forecasts have. Those have become much more skillful over time as we do a better job of predicting atmospheric patterns in general, not just the storm itself, but the steering currents that the storm is embedded in. We're doing a lot better job with that now, but we're still limited by not having any information really about the deep layers of the ocean and how much heat there is there.
Got you. And as you mentioned earlier in the call, that's something, a direct impact of climate change is that the oceans are sucking in most of this warming. They're sort of cushioning the rest of the atmosphere. So we don't necessarily feel as much heat as we should because the oceans are absorbing it. And obviously that keeps going down the water column further and further. So that sounds like that's especially the Gulf of Mexico, which is usually a little bit warmer to begin with, right? It's usually warmer than the Atlantic Ocean.
That's true. And it also applies up along the East Coast as well, where the Gulf Stream, that current that comes out of the Gulf of Mexico and rides up the east side of Florida and all the way up to Cape Hatteras and sometimes farther north than that. That is also a big factor in knowing, how much heat that area contains as well. Because, say when Hurricane Sandy came ashore in New Jersey, again, we were lacking that information about how much heat was contained. And so it actually was stronger than predicted because there was more heat available there for the storm to maintain itself.
Got it. So far we know that climate change has led to greater storm surge from hurricanes. It's made it more likely that these storms can intensify faster. It's made it more likely that storms would show up in category, like the storms that do show up are categories 3, 4, 5 major storms. That's something we even saw a recent paper you mentioned from NOAA came out the other week. Does climate change impact the amount of hurricanes we see? Are we going to see, like, by 2100, is there going to be a zillion hurricanes a year?
That is a really, really hard question because there are so many factors that come into play to determine the number of hurricanes in any given year and the various conditions in the atmosphere and the ocean that may be in place in any given time. So another really important factor in, say, determining the prediction for the number of storms in a year, for example, is what the shear is going to be like in the atmosphere where hurricanes tend to form. Shear is when you have winds blowing from different directions or at different speeds at different levels in the atmosphere. And when there's a lot of shear, it tends to slow down the formation of a storm or even rip it apart. If a storm comes along into an area where there's a lot of shear, it can just rip it completely apart. So how shear is going to change in the future in response to climate change is still a very difficult question to answer. We also have the effects of dust and particles in the atmosphere that can create warming layers up in the atmosphere. So probably your viewers have heard about how we get these pulses of dust coming off the Saharan desert sometimes, for example, and that can have a suppressing effect on storm development or storm intensification. And how in the future, it's really uncertain how those particles of dust, whether they're from a natural source like the desert or from our own production of pollution and how those wind currents are going to carry that dust is another really a difficult question to predict. The models that are used to project the future climate conditions are still relatively undeveloped in terms of their treatment of these different sources of dust and how they affect storm development. So there's still a lot of factors we're working on. Another one is how these temperature fluctuations in the ocean, the natural fluctuations, how those might be affected by climate change. So El Nino, for example, is another one of these natural fluctuations that happens on the Pacific side. And it happens that when we are in an El Nino situation, that tends to create more of that shear in the atmosphere over on the Atlantic. So if we were to get more El Ninos in the future, we'd expect to see that shear occur more often, which would have a suppressing effect on storms. So there's so many factors that have to be taken into account. Probably the one that we are most confident in is that we're going to continue to see more warming because of greenhouse gases, because we are just not slowing down the emissions sufficiently. So that's one almost certain factor, that we'll see continued heating of the oceans, and that definitely has a positive impact on storm development and intensification.
Got it. And I'm really glad you brought up El Nino, because that was something I was going to ask about. So I'm sure any weather watcher who's ever kept an eye on a storm has heard a meteorologist or a forecaster talk about how El Nino or La Nina, which is the other side of it, those conditions affect the frequency and the strength of storms. So can you talk a little bit about what those two systems are and how they might affect Atlantic Basin hurricanes?
Yes, so an El Niños and La Niñas tend to form every few years. They're more frequent than the one I talked about earlier, that fluctuation in the Atlantic Ocean. So this is a more rapid fluctuation. And basically the way you recognize an El Nino, for example, is when there's an area of warm ocean temperatures or warmer than normal ocean temperatures right off the coast of South America, where Peru and Ecuador are. And that tongue of warm water extends out to the west right along the equator. And when we see that tongue of warm water, that is when we know that there's an El Nino happening there. And as I said, when we're in an El Nino situation, that tends to change the atmospheric circulation just a little bit, so that when downstream over on the Atlantic side, we tend to see this, these shear conditions increasing more often. It's not, it's not a done deal, but those are sort of the correlations that we tend to see. The flip side of that, the La Nina condition, is when that same area has instead cooler than normal ocean temperatures. And right now we're in kind of a neutral to slightly La Nina condition. There's expectations for perhaps the La Nina to strengthen somewhat over the summer. And that actually reduces the shear over on the Atlantic side. And so it removes that, that factor that would help to suppress storm development. So those two conditions, really, those warm waters in the whole North Atlantic and the fact that we're not in an El Nino, are the main factors that are leading to the predictions by all groups. They're unanimous this year, which gives it even more credibility that we're going to have a busier than normal hurricane season this year.
Right, and when NOAA talked about their forecast, and other outlets, other academic organizations have talked about their forecast for this year, they definitely point to, if a La Nina does form, which I think the latest results show that it is looking like it's likely to form later this year, later towards the peak of hurricane season, which is the August, September, October part of the year, that it would lead NOAA to more of the extreme end of their suggestions for how many storms we could see. So that prediction, that's why they give a range, right? It's 13 to 19. Yes. So if we see a La Nina form, it could push to the higher end of that. And we could see more named storms form, more hurricanes form, and more of those hurricanes that do form be major storms. Exactly.
And we could also see more dust coming off the Sahara Desert, which is a factor that came into play a few years ago when a busy year had been predicted, but it turned out to be not busy at all. And that's just because we had this very persistent flow of wind off of the Sahara Desert, and it brought a lot of dust over the Atlantic area where the storms generally develop in August and September, and that really suppressed that development. So that's a factor that, again, is really hard to predict ahead of time. So that's, again, why there's a range, because there are these things that can come into play without a lot of prior knowledge.
Got it. And just to talk about that dust a little bit, so my understanding is that either whether it's dust from the Sahara or air pollution from humans on shore, does that impact the cloud formation, right? If we see more of that in the air, we see more clouds which cool the water, which kind of slow things down. Is that a correct interpretation of that situation?
Yep. So that's one response of the atmosphere to having that dust in the atmosphere. The other part, though, is that dust also absorbs solar energy. So it can actually create a layer in the upper levels of the atmosphere that's warmer than normal. And that warm layer can actually stop convection, or the bubbling up of clouds from the surface. So it can actually have the opposite effect. It can, well, it's another effect that would suppress development. So in addition to the cooling of the surface that you just mentioned, it also creates this very stable layer in the upper atmosphere that tends to reduce the upward motions, and that also tends to weaken the development process.
Right. Okay. And we have a question on that topic from the audience. It's a little off, but it's talking about Yeah, so we hear from Greg Hamra about increased dust from the Sahara and how it exacerbates oceanic algae blooms or sargassum, which is, I guess, another impact of seeing all those nutrients come over the wind. Can you talk about that a little bit?
Yeah, it's not really in my area of expertise, but definitely when you get any particles of soil coming from the land blowing out over the ocean, it tends to provide minerals that then dissolve in the water. And oftentimes, if there's a lack of certain minerals that are limiting the speed that algae can develop, then it might cause additional blooms of algae in the ocean in places where we don't normally see it. But it's really only when there's already a limit to whatever those nutrients are. You know, some places have plenty of nutrients, and so adding more isn't going to make more algae. So, but generally in the middle of the ocean, there tends to be a shortage of nutrients. So you would tend to see more algae blooming. Sargassum, I see, is also part of that question. Sargassum is more of a seaweed. It's a larger clumps, and we're already seeing massive mats of sargassum forming in the tropical Atlantic areas. It's been blowing on shore. People in Florida are very familiar with this very stinky, massive dumps of this sargassum weed when the wind is out of the east. And it's affecting areas all down through the Caribbean as well. And I don't think that anybody's really figured out why it's increased so much lately, but perhaps these nutrients from the Sahara are playing a role. That could be.
So speaking of things that come over for the Sahara, that's often where we see hurricanes form, is off the coast of Africa. Is global warming and climate change affecting where storms are more likely to form? I know halfway through the season, we generally see a shift in where more storms more frequently are formed.
Right. So in August and September, we tend to see the storms sort of starting off way over on the African side of the tropical Atlantic. And that's because we start to see these waves in the intertropical convergence zone, which is this also known as the doldrums, perhaps, where the two sides of the trade winds meet, and it's always a lot of thunderstorms and squally conditions right there. And that zone moves northward in our northern summer, and then it shifts southward again in the northern winter. So when it moves north, which it's doing right now, and it reaches its peak, say in that August-September timeframe, we get this area that's already kind of disturbed and stormy. And then if a little wave forms just on that sort of east-west line of storminess, we call that a tropical wave. And that can set off the spin and the extra upward motions that get hurricanes forming. And so that's why it tends to happen in August and September. It's exactly when that doldrum area of storminess is farther north. And so it's more susceptible to being affected by other weather patterns to the north that can cause these waves to generate off of the coast of Africa right there and get them going.
And are we seeing any impact to when that system when we start to see these tropical waves form there, or where they're born because of climate change? Are we expecting any impact?
I wouldn't expect to see a real signal there, because really that shift of the doldrums is driven by the seasons, and the sun is not changing, you know, how far north it goes, how far south it goes, and the timing of all that. That's all orbital mechanics. So I wouldn't expect to see a big change really because of that. However, as I've already talked about a lot, how the oceans are so much warmer now, it could be that there are areas where the ocean maybe was a little too cool before to get a storm going. And now that the oceans are warmer, you're sort of meeting that threshold temperature in places where you couldn't before. And so we might see that storms are able to form, say, a little farther north or a little farther east than they did before, just because of that extra warming in the oceans. And that said, we might also see storms able to survive farther northward. So as they come across and they curve up along the East Coast, say, they may be able to survive as a tropical storm farther north, again, because of that overall ocean warming.
Right. So I think that we've seen in the past couple of years some oddball storms, one that took a turn almost toward Portugal, and some that have gone a little bit higher on the East Coast than we've seen before. So is that has to do with climate change, right? That's a signal, or is it natural variability of just, sometimes storms go haywire and go odd places in the world?
Well, we can't point to those exact storms and say that climate change caused that erratic behavior, but it does make sense that, as I said, storms are probably now going to be able to travel farther northward and stay tropical, and also across the Atlantic. Like, I think that was Leslie last year, tropical storm Leslie, that almost made it all the way to Portugal as a hurricane. But we can also think about how storms are going to be able to survive later into the season as well. And there is some research suggesting that there were more late season storms. So you can think about Sandy was at Halloween. So was Hurricane Florence, the end of October. We're still in technically the hurricane season, but we're seeing more of those very late season storms, most likely because those ocean temperatures are just that much warmer now and can maintain those tropical storms longer.
Right. And I guess, this year was the 6th year in a row we saw named storms form before the official start date of hurricane season. So this is sort of maybe another signal that the conditions in which it is appropriate for a hurricane to form or a storm to form could extend to more parts of the year, right? It could be a longer hurricane season.
Yes, it could very well. And, we almost had 3. There was another disturbance that almost made it to be a tropical storm right before May ended. It never actually made it. But so, we came very close to having the very first year ever with 3 tropical storms forming before the official season started.
And we're still on track to break a record. Even maybe it could have happened in the last half hour, but sometime today, the National Hurricane Center has been watching a tropical depression that is formed off the coast of the Yucatan Peninsula down in the Bay of Campeche off of the coast of Mexico. And it's expected to strengthen into our 3rd tropical storm of the season, Cristobal, which would be the earliest 3rd tropical storm ever formed in recorded history.
Yeah, it's not looking good for this year.
No, very active season so far. So this is a great reminder to everybody that it's hurricane season now, and they're starting earlier, they may be ending later. It means it's always time to be prepared and make sure you have your hurricane kit set, you have your evacuation plan, you've got everything you need. We've got resources on the Miami Herald website if you need any of that. Our hurricane page, we've got a hurricane Facebook group. FEMA and Miami-Dade both have excellent resources on how to make sure you're prepared. So you know your zone, know that if the evacuation is called, you have to go, know if storm surge is coming, if you're at risk, and know where you can go, know your shelters, know all of that stuff. So there's lots of information out there. Use this opportunity when we're not currently facing any threat right now from any storm. It's a great time to learn as much as you can about what you need to be ready. And even make sure you've got everything for your hurricane kit now. Buy those battery-powered fans and your radio, all of it. Then you don't have to rush with everyone when a storm actually hits.
And I would add to that, preparations when a storm is threatening are going to be that much more difficult this year because of the pandemic. So, it's going to be more complicated to evacuate people. Shelters are, they're trying to figure out how to deal with shelters when we have to stay 6 feet apart from each other. And already emergency supplies are depleted. So cities all up and down the East Coast are reporting that they're definitely not as ready as they would like to be because of these extra challenges that we're facing this year.
Absolutely. That's why it's more important that you don't, have to wait in those long crowded lines at Walmart or Target or Publix when we get the call that it's time to prepare for a hurricane. If you have the opportunity to get your stuff together now, put a mask in your kit this year, hand sanitizer, soap, gloves, disinfectant wipes, all of those things this is an unusual hurricane season. It's going to be an active one, and we are looking at it on top of a pandemic. There are resources on the Miami Herald website about what the season looks like and how Miami-Dade and the state of Florida are handling that. If you want to lead more, we can put that in the comments as well. But Dr. Francis, I think that covers most of what I wanted to talk about today. Is there anything we missed about hurricanes and climate change you think is important to talk about?
Well, I think I'd just maybe like to emphasize that people are, I think, paying more attention to the fact that we are creating an environment now that is making these storms more vigorous. They're developing more rapidly. It's a communication. If there's a silver lining to this these several dark clouds that are swirling around these days is that I think people are realizing that that the scientists are right. You know, we've been saying this for a long time, and you know, Mother Nature is showing us now that that this is really happening and that we really need to do something about it. So the only way we're going to slow this trajectory that we're on right now is to all of us take part in figuring out ways to use less energy and emit less carbon dioxide, and get our leaders to do the same, and to vote for leaders who get this problem and are willing to do what it takes to ameliorate it.
Right. And that's something that South Florida leaders have been talking about. If you want to join the conversation with them, there are plenty of activist groups, there are plenty of nonprofits. You can come to any city, county commission meeting and speak up and talk about what you'd like to see in terms of climate change and protection and use of energy and all that sort of stuff. So as we've talked about today, to summarize a little bit, hurricanes and climate change, they're complicated. There's a lot to it. They don't have a necessarily straight interaction between the two, but scientists have shown that as we look at hurricanes in the future, climate change is more likely to make them stronger, wetter, slower, and it's likely to make storm surge much more intense in areas along the coast. And all of that should be concerning to anyone who lives in any area that's threatened by hurricanes, specifically South Florida. So thank you so much, Dr. Jennifer Francis, for joining us today. It was wonderful to talk to you about this. And thank you, everyone who tuned in. We really appreciate your time today.
Thank you, Alex.